Monday, week 5 already. Reminder on Tuesday, Tech Club Volunteer Fair. Advanced Hardware, students took the quiz to review the concepts. We reviewed the topics, took the exam, then we got started on troubleshooting some topics. We really didn't do any labs. Wednesday we'll take a look at preventative maintenance some more, and maybe even start looking at networks. Yeah, we will. We'll get started on networks. So, here we go. We reviewed these concepts. We talked about post, BIOS, CMOS, UEFI. Talked a little bit about updating that firmware, making sure you go to the vendor and take a look at that. We talked about voltage, current, amps, and ohms, how this, obviously affects, or maybe even so obviously, computing, because we use that in terms of how the computer functions. Alright. Talked about the difference between blackout, brownout, noise, spike, power surge, and then talked about surge protector, uninterrupted power supply, and then a extra power source. We give the example of the ICN here on campus, Iowa Communications Network. They have batteries, they have UPSs that run inside, and then they have a generator motor outside the building. So if the power's off for a certain length of time, that kicks in to send power into here, which then takes care of these and then gives us the right watts, voltage, etc. to power the equipment. Talked about monitors, all the specifics from the chapter on monitors. We talked about thick clients and thin clients, thick clients, hard drives, and RAM, and the PC is basically everything you need in it. Thin clients need to access network resources. So it really a processor, memory, not much for storage, because everything's done in network access storage as an example here. Store things specifically there. Talked about, this goes back to the monitors, or goes to the monitors. Talked about VGA, DVI, HDMI, and display ports. We actually looked at an example of a cable and a display port. CPU, a couple major companies, Intel, AMD. Clock speed, front side bus, how many bits, and how many gigahertz. We looked up machines in the room, 3.4 gigahertz. Clock cycles, how many cycles it can perform per second. This is a lot. So this has a lot to do with performance of your PC. This tied into how much memory. Clocking, overclocking for performance, throttling down for cooling, and longer lasting PCs or processing units. Virtualization is this ability to run multiple, for example, OSs and make good use of this power of the CPU. It's hard to keep the CPU busy, so you can distribute that power, especially when you have multi-cores and so forth. by virtualization, we can run multiple operating systems to take advantage of this power. This is done a lot in data centers, where people can purchase compute time. So, dealing with the processors, we talked about multi-core, graphic, and how to cool them. Alright, the software, in order to take advantage of that, the software has to be designed to take advantage of that. Talk about maintenance. How do we take care of the physical part? How do we keep software updated in order to maintain the computer? So that was the next chapter. But RAID, the different ways, stripping across drives, mirroring, mirror the drive, parity, the making sure you have the error checking with the drives, and double parity is better. So we talked about different levels of RAID. 0 stripping, 1 is mirroring, you have to have at least 2 drives. Striping parity, you have to have multiple drives, at least 3. This is better, you have to have at least 3 drives. Striping and mirroring. Takes, you have to be aware that for striping, I said striping, you would, you can remove one of the drives and then rebuild it, but it'll take a while. Take even longer here, even longer here. But here you could remove 2 drives and still retain your information. RAID is not, it creates redundancy so you don't lose anything, but it's not backup. Backup, you would have to take the information off to another site. So it's not the same thing. The last thing we talked about, frequently asked questions. We talked a little bit. We said you have an issue, a problem. So we have this cycle. First thing you need to do is identify the problem. What's actually wrong? Some theory on how what you think might be wrong. Then you test those. Then you create a plan to implement that. This is the whole idea of feedback. You test something, check, test something, check. So you have it like this feedback loop. You get a plan, check it, make sure it works. Put it into place, verify everything, not just the problem, but is it, did you not create another problem? Then we document everything. In the process, you have the client involved. We'll talk more about that today, actually, or the next class session. That's it.